So this video is the first video on Unit 9. It's going to cover lessons 1 and 2, which in your foldable notes little packet there, it is the top two sections, 9.1 and 9.2. So lesson 1 is all on an introduction to what it means to be an imaginary number or a complex number. Those two words, they mean the same thing. So another word for imaginary is they may use the word complex. A complex number usually includes a real part and an imaginary part, whereas the imaginary part is only the imaginary part, or an imaginary unit. So remember back in last unit how we told you that you couldn't ever take the square root of a negative number. You just wouldn't get an answer if you got a negative underneath the radical. Like the square root, if you got the square root of negative 10, we told you that can't happen, so you just would say there's no answer. Well, we kind of fibbed to you. We did that just because we haven't learned about imaginary numbers yet, but now you are. So this is the very first lesson that is kind of brand new. You've never seen this before. You haven't seen it in Algebra 1. So if this happens, if you get a negative underneath a radical, it doesn't mean that there is no answer. It means there's no answer in the real number system, which means you won't get an answer that you could like plot on a number line. You're going to get an answer that is imaginary. And you might be wondering, well, what does that mean? It's okay if you ultimately don't understand what it means. You just have to know how to work with them. We, in the real world, use imaginary numbers. Primarily the most popular, I guess you would say, area where you would see imaginary numbers is when you're talking about electricity. It's used in electricity a lot. So if you never have to deal with electricity or working with electricity, you may never see imaginary numbers in your life. It's obviously also used in the quadratic formula because it involves a radical. And it is also used in biology a lot when you're talking about brain waves. So depending on what field you go into after high school, you may or may not ever have to deal with negative or imaginary numbers, which would be negatives underneath square roots. So let's talk about what it means to be imaginary. First of all, the variable or the notation for imaginary numbers is a lowercase cursive looking I. I for imaginary. It's actually one of the variables that it actually makes sense why they would use I for imaginary. So it is defined as the square root of negative 1. So if you got, for example, the square root of negative 10, whoops, I've got the negative in there. Do you agree? I could rewrite that as the square root of negative 1 times the square root of 10, which now I just told you what the square root of negative 1 is. We're going to rewrite that as just I. So this is I times the square root of 10, and that would be your answer. So if you ever see an I in your answer, that means that there was a negative underneath the radical, but we kind of pulled it out as an I. So then we can talk about it. That kind of makes more sense to us to say the square root of 10, but it's in the imaginary world. It's in the imaginary numbers. It's not in the real world or the real numbers. Well, it is in the real world, but it's not in the real number system. It's in the imaginary number system, but it's the square root of 10 in the imaginary, is not in the real numbers. So here's an example. Here's a couple examples. So you're going to take these negative square roots and rewrite them in the imaginary number system. So the square root of negative 4, and once you get good at this, you don't have to do this step, but I'm just trying to show you why it is what it is. So I'm going to rewrite the square root of negative 4 as the square root of negative 1 times the square root of positive 4. Now I have an imaginary part and a real part. I can take the square root of 4. I can also, in the imaginary world, take the square root of negative 1. So what I'm going to do is I'm going to turn those into what I know they are. The square root of negative 1, I just told you we can call it I for imaginary. And then the square root of 4 is 2. Now, usually we write, when you have something like this, you treat I as a variable. And usually, like if that were an x, you would treat it just like you would an x. You wouldn't call it x times 2, you'd call it 2x. So I'm going to rewrite this as 2I. And that's your answer. The next one would be the square root of -1 times the square root of 45. Now, the square root of 45 is not pretty, but I can break it down. We did this last unit. 45 is 9 times 5. 5 is prime, and 9 is 3 times 3. So there's 2 3's. So the square root of 9 is just 3. 5 doesn't have a partner to circle, so he stays under the radical. So this reduces to I times, and then we broke this down to be 3 radical 5. Now, I usually, again, treat I as it would be an x. We usually don't put the x first. I would rewrite this as 3I radical 5. Remember, multiplication order doesn't matter, so I rewrote it with the 3 in front of the I instead of the I in front of the 3. Okay? Now be careful, because if the negative is out in front of the radical, that's a real number. That's not going to be imaginary. It's only if the negative is under the radical. That's when you use imaginary or I, okay? Now, you do have to know, you'll see this little circle over here. You have to know the first 4 powers of I, and the reason why you only have to know the first 4 is because after the 4th, it repeats. It's a cycle. That's why it's written in a circle form. So I just told you, so anything to the 0, I'll start up here, anything to the 0 power in the entire world, you know, equals 1. So anything to the 0 is 1. I to the first is just I. Okay, so if you have I to the first, you don't have to write I to the first, that's just I. Now I squared, if you think about what I to the first equals in terms of imaginary numbers, I to the first, okay, I squared can be written as I times I. Hopefully you understand that. I to the first times I to the first is I squared. Well, if I rewrite what I is in terms of radicals, it's the square root of -1 times the square root of -1. Well, when you multiply 2 radicals together, the radicals kind of cancel each other out, and you're left with just what's underneath them, which is -1. So therefore, I squared is equal to -1. Now, I to the third, hopefully you realize that I to the third can be written as I squared times I to the first. Well, if you take what both of those equal, that would be -1 times I, which is -I, -1I. So that's what the first 4 powers of I equal. Now you might be saying, well, how does that help me? Well, anything after the first 4 starts to repeat. So that means I to the 4th is the same as I to the 0, which is 1. I to the 5th is the same as I to the 1st. I to the 6th is the same as I squared. I to the 7th is the same as I to the 3rd. I to the 8th is the same as I to the 0. And you can keep going. So I to the 9th, I to the 10th, I to the 11th, I to the 12th, I to the 13th, and so on. So you might be thinking, well, what if they give me a huge number like down here? What if they ask me like I to the 122nd power? You're not going to sit here and count to 122 to figure out which one it's equal to. Here's the shortcut. You are going to divide the exponent by 4, because every 4th I, it starts to repeat. And then you're going to look at the remainder. So if there is no remainder, that would be a 0. So that exponent, that I, would be equal to I to the 0. If there is a remainder of 1, that would mean it's equal to I to the 1st. If there's a remainder of 2, it's equal to I to the 2nd. If there's a remainder of 3, it's equal to I to the 3rd. So that's how you tell which I that I is equivalent to. So let's do an example. I to the 8th. I'm going to do in my head or on my calculator, 8 divided by 4. That's 2 with a remainder of 0, right? There's no remainder. So that means I to the 8th is the same as I to the 0, which I know equals 1. So that means I to the 8th, I don't really have to write this middle step. It's equal to I to the 0, which is 1. Now let's do the next one. I'm going to take 38 and divide it by 4. So 38 divided by 4, if you use a calculator, it tells you it's 9.5. Well, you might be thinking, wait a minute, it can't have 0.5 does not mean remainder of 2. Or, sorry, a remainder of 5. It means a remainder of 2 because 0.5 is otherwise known as 9 and 2/4 because you're dividing by 4. So the remainder in this case is 2. So that means I to the 38th. If you sat here and counted up to 38, so you would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way up to 38, you would land on I squared because it has a remainder of 2. So I to the 38th is the same as I squared, and I squared equals -1. So -1 would be your answer. All right, the next one, 83. If you divide that by 4, the remainder, so 83 divided by 4 is 20.75. Well, 0.75 is not your remainder. Your remainder would be, if it's out of 4, that's 3 out of 4. So I to the 83rd is the same as I to the 3rd, and I to the 3rd is -I. So that's your answer, -I. Now this one's a little trickier because there's numbers out in front. Well, they stay what they are. That's just a 5. You need to figure out what I to the 16th is equal to. It's either going to be 1I, -1, or -I. Well, if you divide 16 by 4, there is no remainder. So that means I can rewrite I to the 16th as I to the 0. Plus 23 divided by 4 is 5.75. That means it has a remainder of 3 because that's 3/4. And then 26 divided by 4 has a remainder, it's 6.5, so that's a remainder of 2. So that's the same as I squared. Now I'm going to rewrite what each of these i's equal up here from my chart. I to the 0 is 1. I cubed is -I. And then I squared is -1. And now I'm going to combine my like terms. So this is 5 minus 1, that's 4. 3 times -I is just -3i. You treat the i's like you would variables like x's. So in your head, treat that like it's an x. And then you just combine your like terms. So that actually kind of leads us into the next lesson, 9.2. Because in this lesson, we are adding and subtracting or multiplying with complex numbers. So again, like I just said from the last lesson, you're going to combine like terms and you treat the i's like you would x's. So you can only add like terms. That means you can only add the real parts with other real parts and the imaginary parts with other imaginary parts when you're adding, just like you would. If I gave you this, if I gave you like 3 plus x plus 5 plus 2x, okay, you would only add the 3 with the 5 because those are like terms, that's 8, and then you would add the 1x with the 2x, that's 3x. Well, it's the same idea with imaginary numbers. You treat the i's like you would x's. So if I look at this first example, the first thing I have to realize though is that I'm subtracting this whole second thing. So that means I have to distribute the minus sign to both things. So I'm going to do that first. I'm going to drop the parentheses in the first one because there's nothing out in front to distribute. But in the second one, I have to distribute this minus sign to both things in the back. So that's -3 plus 6, or sorry, I was distributing a 3 in my head for some reason. It would be plus 2i. Now you're going to combine your like terms. So I can combine my 2 with my -3, so that's -1. And then I can combine my i's, so that's 5i and 2i, so that's 7i. So that's your answer. You cannot combine the -1 with the 7i because they are not like terms. If they both had i's, you could, or if they both didn't have i's, you could, but one has an I and one doesn't. Okay, and then the last one is multiplying. Same thing, treat the I like you would an X. So when you are multiplying, you can multiply, remember, like if you had negative 10 times X, you kind of can multiply those together. You would just call it negative 10X. Well, same thing here. Negative 10I times 2I is just negative 20I squared. And then going back from lesson 1, you know what I squared equals. I squared equals negative 1. Now, a negative 20 times a negative 1 is a positive 20. So your final answer is positive 20. The next example, you're going to multiply this out. Remember, if you need to in your head, just imagine that these i's are x's. How would you multiply this out if those were x's or any other variable? You would double distribute. So 2 times 3 would be 6. 2 times negative 5i is negative 10i. And then you would distribute the second guy, so that's positive 9i. And then a 3i times a negative 5i is a negative 15i squared. From here, you have to clean this up. We can combine our like terms and turn I squared into what it's equal to. It's equal to negative 1. So this would be 6 minus 1i, which I don't really need the 1. You can just call it minus I. And then minus 15i squared is equal to negative 1. Well, a negative times a negative is a positive. So this turns into 16 minus I plus 15. And now I can combine my real parts, my like terms. 6 and 15 is 21. The I has nobody else to combine with because there's no other I, so it's just 21 minus 1I. All right, the last one. Remember when you're squaring a quantity that's really 2 of them? So I have to write it out. Negative 2 plus 3i radical 2 times negative 2 plus 3i radical 2. Remember, radicals you also treat like variables. You can only multiply radicals with other radicals. If you're multiplying a radical with a non-radical, it just stays like radical 2 times 4 would just be 4 radical 2. You can't multiply the 4 into the radical. It just kind of stays out in front. So if you double distribute, negative 2 times negative 2 is positive 4. Negative 2 times 3i radical 2. Well, the only number that negative 2 can multiply with in this guy is the 3. So that's negative 6i radical 2. The negative 2 can't multiply with the I because they're not the same, and then the negative 2 can't multiply with the radical because it's not the same. You can only combine radicals with other radicals. All right, now multiply this guy. So that'd be negative 6I radical 2. And then the last 2 that you multiply together, there's a bunch you can multiply because there's a real number with a real number. That's 9, positive 9. I times I is I squared, and radical 2 times radical 2 is radical 4. Now I'm going to clean it up. These are common terms. These are like terms, so I can combine them into one I radical 2. So this is 4. A negative 6 and a negative 6 is negative 12I radical 2's. And then, oh, I forgot to write the squared. Sorry, I said it, but didn't write it. It would be 9I squared. I squared I can rewrite as negative 1, and the square root of 4 I can rewrite as 2. Now I'm going to simplify this. 9 times negative 1 is negative 9, times 2 is negative 18. So this turns into negative 18, and now I can combine my like terms. 4 minus 18 is negative 14. There's nobody to combine with this guy, so he stays negative 12I radical 2. That's your final answer. Don't freak out if this sounds like a foreign language to you. We are obviously going to practice this. The only thing I really want to make sure you start memorizing is this circle, this cycle of i's. You have to have them memorized, how to figure out which I any I is equal to, and then you have to have memorized that anything to the 0 is 1, I is just I. But these two are really important. I squared is equal to negative 1, and I cubed is equal to negative I. You have to have that memorized before this unit test and for the rest of the year. So that is it for this video, and we are going to actually finish up this unit next video because it is only 4 lessons long.